Okay, so we're going to talk and review a little bit of what you guys worked on yesterday, kind of make sure you get it. But we started with this form of parabola, and this has to do with motion. This is using feet or feet per second. There's a different value for this if you're in meters, which when you take physics and science, you will do it in meters. Okay, so this V0 means initial velocity and H0 means initial height. So your example was launching a pumpkin. So if I launch a pumpkin with an initial velocity of 80 feet per second from a height of 12 feet, I can get this equation. Let me make my first T a little bit neater there. Okay, and this is a quadratic equation in the standard form. The standard form looks like ax squared plus bx plus c. If I want to know the height of the pumpkin when at 1 second, I just plug in 1 for t. Oops, that one should be squared. Okay, and I get negative 16 plus 80 plus 12. 76 feet. If I want 2 seconds, I plug in 2. Um, 2 squared is 4 times 16 is negative 64 plus 80 times 2 is 160 plus 12 is 108. If I want the y-intercept, I plug in 0. Because the y-intercept on the y-axis has an x-coordinate of 0. And these two terms just become 0, and I'm left with 12. So C here on the standard form is going to be my y-intercept. So ax squared plus bx plus c. A, b, and c represent different numbers, and they can vary depending on the quadratic model or quadratic equation. But they allow us to get our different forms. We're going to do some things like solving with these, and we'll do some factoring as they're coming up. So for today, that's a little bit on what yesterday's was. So if you struggled with yesterday's, you can go ahead and do this. If you're solving them for different values, make sure you go ahead and use Desmos. And you plug in your equation. Let me switch which screen I'm sharing here. Plug in our equation to Desmos. When using Desmos, you must use, the t's must become x's. I need my negative. And I see something that's really quite steep here. And I clearly don't have anything near the top, so I'm going to, I don't know how high this is going to go. I'm going to go with, the book has 260 in it for one of the heights you're supposed to get, so I'm going to go with 300. And I can tell that it doesn't get close to, does not even get close to 260. So that's never going to happen on this one. But if I want to get, say, what time is it at 80 feet? That wasn't exactly 1 second. So over here, I'm going to plug in y equals 80. I'm actually going to find 2 different times. It's going to be at 80 feet on its way up, and then again on its way down. So I've got 1.086 seconds and 3.914 seconds. Okay. So everything but this maximum height is actually the vertex of the parabola. We call this key point at the top or the bottom if it's an upward opening parabola, the vertex. And that's going to give us our maximum. Every other point on a parabola is going to have 2 values. Now this, if we're realistic about this one, anything in the negatives, you can't have a negative time since my x coordinates are time. So yeah, it's 0 here twice, but one of them's negative, so that's not really meaningful. And negative y values are not really meaningful. But as far as just a true parabola, every one's going to have 2 points. Okay, today's lesson is about building parabolas from linear functions. Okay, so I can have 2 different linear functions. So this is 2x plus 5 has a slope of 2 and a y-intercept of 5. This one has a slope of 1 and a y-intercept of -4. Well, if I multiply them together, we get what's called the factored form of a parabola. Factored form means it's as broken down as it can be. These are what's called linear factors because each factor came from a linear equation or is a linear equation. Hopefully you guys are familiar with FOIL, where I multiply together my first outside, then inside, then last. So that's 2x times x. 2x times x gives me 2x squared. 2x times -4 is -8x. 5 times x is plus 5x. 5 times -4 is -20. I can combine my terms. That -8x plus 5x make -3x. And here I have a quadratic in factored form. Or not factored form. This was factored form. This is standard form. So these different forms of quadratics, I can exchange between them so that to convert different forms. Different forms are useful for different parts. Okay. We're going to get to it in more depth later, but this is going to help me find the x-intercepts in this form. Because the x-intercepts, when I have an x-intercept, that means y equals 0. Okay. And I know that 0 times anything is going to be 0. So if this factor, 2x plus 5 equals 0, the whole thing will equal 0. And since this is just another form of that, if this equals 0, then so will this. Now I can just solve 2x minus 5 equals 0. And I get x equals -5/2. Or X minus 4 could equal 0, would still be 0 times anything is still going to give me 0. So this one, like I showed you on the graph, is going to have two answers. Both X can either be -5/2 to make this 0, to make Y 0, or it can be 4. And those are my two solutions.